The last little video in fluid statics is on the phenomenon of surface tension. What is surface tension? Well, at the surface between a gas and a liquid, the relationship between the molecules in the liquid change. So you have in the liquid, you have a certain amount of attraction and repulsion between all of the molecules, and so they stay relatively well spaced. But at the surface, um, the molecules of the liquid are more attracted to each other than they are to the gas, and that pulls these molecules at the surface down because there's nothing pulling them up here, and so they get pulled down more tightly at that surface level than they do in the body of the water, and that creates this phenomenon called surface tension. And it acts a lot like a string that is stretched across here. These molecules are tightly attracted to each other. And so if I try to push up or pull down on a string, I get a restoring force. It wants to return it back to a straight line. Well, the same thing happens here. If I push down on this surface, I'm going to get a restoring force that tries to pull that surface level again because those molecules are so tightly strung together. We write that surface tension, and this is a quality of not only the liquid fluid, but a combination of the liquid and the air fluid in the units of newtons per meter. Okay, so the effect of this tensile force here amongst these molecules is this here, which is a force per length. So the longer the contact area that I'm trying to push down, the more force I'm going to have pushing up. And that's what surface tension is. If we want to calculate that first surface tension, we're going to take that coefficient for surface tension. Remember, this is a material coefficient that has to do with the nature of the fluid and the air, that interaction between those two, times the length of whatever we're putting into or disturbing that surface tension with, right? So you look at the water strider here and notice how its legs sort of slant and flatten out as they go into the water. That makes that L bigger, and that makes the force holding up our water strider larger. And you can see that force here. This is, say, the water strider's leg. It's pulling that string of molecules at the surface down. And there's an upward force right here and right there. And the Y component of those two forces are counteracting this weight force. So the weight force wants to sink into the water, but the surface tension pulls the object back up, or pushes the object back up. Surface tension leads to a number of interesting phenomena like water striders, a needle floating in the water, droplets forming on the surface of like an oiled solid surface, and also the fact that water droplets are spherical. All of these have to do with the idea of surface tension. And so we'll close with the question, why does a needle float if you lay it carefully on its side in water, but not if you put it in water point first? And the answer to that is our L up here, right? This guy is a material coefficient. This refers to the particular situation. And so if I put that L flat on the water, or that needle flat on the water, my L is going to be bigger. My force, my restoring force here, might be strong enough to hold up that needle. That's surface tension.